Let's finish up the week talking about inverse functions, all right? Okay, here we go. Regular functions. Regular functions, we use the notation f of x. Okay. How do you know if something's a function again?
If it's vertical axis.
Very good. Okay, it's got to pass the VLT. All right, if you're going to be considered a regular function, now f isn't the only letter we could use. We could use g's or h or p or t or anything else. F is just a very common one to use for function. All right, today we're going to talk about inverse functions. An inverse function is notated with a little -1 right there. And we read that just f inverse. We don't say f -1, we just say f inverse of x. There's an additional requirement for an inverse function. It has to pass both VLT and the horizontal laying test, the HLT. If it's going to be and have an inverse function, okay, it's got to pass both of those tests. So what we're going to learn today is how to create inverse functions out of regular functions. So how do we create or how do we make inverse functions if we're given an original function, an original regular one? There's two ways. The answer to the question is twofold. There are two ways. One, you switch the x and the y values. Values are numbers. It's really easy to do. If you want to create an inverse function, all you have to do is switch the two numbers around. Let me show you what I mean in a couple examples. So suppose you have an f of x and it's given to you as a table. And the table looks like this. 1, 2, 3, 4, 5 across the top. 6, 7, 8, 9, 10 across the bottom. We usually assume that x's are on the top and y's are on the bottom, unless we're told differently. So it's so easy to create an inverse. You just say f inverse then, and you switch the rows of the table, because all you're switching are all the x's with all the y's. So instead of 1 being with 6, it's 6 being with 1. Instead of 2 being with 7, it's 7 with 2. And you do that all the way down, 9 and 4, 10 and 5, and you just created an inverse. And that's it. It's really quite basic when you're working with numbers. Another example might be the dots on a graph that you switch. So suppose you have, yeah?
So if we switch, is the y still on the bottom?
No. So the x still on the top and the y is on the bottom, the new x's. The new x's are the old y's.
Okay.
The new y's are the old x's. Yeah, they switch. All right, so suppose you're looking at a graph and you've got dots on the graph. And I'm not going to draw the graph for you, I'm just going to tell you where the dots are. So suppose there's a dot at -5, 2, and maybe another dot at 4, -1, and a third dot at 3, -7, and a fourth dot at 10, 14. And you're asked to create the inverse. So you're going to take those 4 dots and you're going to create an inverse by just switching the values of x and y. So you'll have 4 different dots, maybe in a different color if you're doing it on your iPad. But -5, 2 becomes 2, -5. I just switch the order of the values. The x becomes the y becomes the x. 4, -1 is -1, 4. -7, 3 becomes or 3, -7 becomes -7, 3, and 14, 10 becomes, I said it backwards again, 10, 14 becomes 14, 10. And those are the new 4 dots of your inverse. Okay? Are we okay? Is this not so bad so far? Okay. All right, that's step 1. That's way 1. How do we create inverse functions? You switch all the x's and the y's for their values. Okay, method number 2. Okay. You're going to switch the x and the y variables. This takes a little more algebra work. It's not quite as easy as just flip-flopping numbers around. You're going to switch the x and the y variables. So let me show you how that's going to go. So let's say our first original function is 4 plus 2 over x over 3. By the way, you can't find an inverse if it doesn't pass the VLT and HLT to begin with. You should probably check. I snuck one into your homework that doesn't pass the VLT and HLT, and so then that's supposed to save you work, so you don't even have to do it. Just write, can't do it, failed the HLT or failed the VLT or something. This one passes, so it happens to pass both. But get in the habit of checking. All right, well, if I'm telling you to switch the x and the y variable, the problem is there's no y variable. There actually is a y variable. Does anybody know where it is?
F of x.
Yeah, f of x is the y variable. So first you're going to replace it. That's not a switch, that's just a replacement. 4 plus 2x over 3. So I'm not switching them, I'm just putting y in. Now I want to switch them. To create the inverse, I switch the positions of x and y. So x becomes y and y becomes x. Nothing else changes. Don't change the 4, the 2, the 3, just switch the x and the y. So then you're going to get x equals 4 plus 2y over 3. Now you want to solve that so you can have y by itself. The quickest way to solve that is to drop a 1 under the x, because what does that allow you to do? As soon as we drop a 1 there, cross multiply. Okay, so we're going to cross multiply. We'll get 3x equals 4 plus 2y. And I keep wanting to do things to both sides here. I want to do something to both sides so I can work on getting this y by itself again, so it's no longer by itself. So my next step is to subtract 4. That gives me 2y. I'm really close to having y alone. I'll divide both sides by 2. And y was only temporary. Y was replacing f of x at the beginning, so I need to replace it back. But when I replace it back, I replace it with the inverse because I just completed the inverse process. So we finish with 3x minus 4 over 2, and that is equal to the inverse. All right, so let's back up and review that. You change f of x to y because they are equal to each other. Cross multiply and resolve so that y is back alone again, and then change it back to the inverse notation. Let's try another one of those for practice, and then we're going to call it a week. Okay, yeah.
Can you write the inverse x as f of negative x?
No, that is something different.
Okay.
Okay. That is the opposite, not the inverse. The opposite and the inverse are two different things. Okay, the cube root of x plus 3 minus 1. The good news is this passes both again. Okay, passes both the VLT and HLT. And so then my job is to find the inverse. I need to switch the x and the y, but there isn't a y at all. So I need to bring a y into the equation. So this is y equals the cube root of x plus 3 minus 1. Now that I have a y to switch the x with, I will flip-flop those two positions. Don't move anything else. Just make the problem start with x equals instead of y equals. And then have everything else. Oops. Now you're going to work, after you've done the switch, then you're going to work towards getting the y by itself again. Okay? All right, Sydney, any ideas? Are you caught up that far in your notes? What could I do to both sides? Trying to get y by itself. What would be a good move here?
Well, I would say square, but you could cube it.
I am going to cube it, but I can't do that yet. Okay, so hold on to that thought. Good thought. I need to add 1. That would be the first thing I need to do. All right, so I need to add 1 to both sides. So I'm going to have x plus 1. And now Sydney's idea of cubing it is a really good idea. I need to use parentheses to cube both sides. So even though her idea is good, sometimes people will do it wrong by not using parentheses. So we want to cube on both sides. You can't distribute a cube though. Okay, you can't take this 3 and just drop it on both of those numbers. That's not how cubes work. Okay, oh, you were trying to do it? Okay, a cube would mean you would have to put an x plus 1 times an x plus 1 times an x plus 1, and you would have to FOIL the first two, and then you'd have to super FOIL the last one, and then you get a really long thing. Okay, you can't, it's easier to just leave it the way it is. X plus 1 cubed, okay, just leave it. Don't do more than you think you need to. But what happens on the other side is the cube root goes away. And then the last thing that I need to do to help me get this alone is what, Rachel? Yeah. And so we're going to have x plus 1 still with its cube around it, and we put the subtract 3 after, and it looks like that. So your final answer would be to replace the y with now the inverse equation. So inverse notation, g of x is equal to the cube of x plus 1 minus 3. Okay, the domain of this is all real numbers because it doesn't have an even root and it doesn't have a denominator. The same rules for domains still apply. You just look at the answer and see, does it have a square root? Then there's an exception to the domain and you have to figure it out. Does it have a denominator? Then there's another exception to the domain. You got to figure it out. Okay, both of the results here start with all real numbers, and there's no square root in the answer, and there's no x in the denominator, so I don't have any restrictions. Okay, Jared.
So, for their test, if we had like x plus 1 cubed, would you make us solve it?
Nope, I want you to leave it. I want you to leave it for sure. Okay, you're going to need to leave it for the rest of this chapter, so it's good to leave it that way. Any other follow-up questions?